Okay, we're good. It's recording.
Okay, cool.
Yeah.
All right. So first of all, I want to thank everyone for being here. There's so many people, the attendees, the panelists. I want to thank Kanika for putting this together. It was her idea from the very beginning. She got the hosts, she got the panelists, she got the questions. She did everything. So to begin with, my name is Jay. I'm a third year undergrad at University of Waterloo. I'm studying physics, and I'm on the external affairs exec team at the club. I'm going to be hosting the panel with Kanika today. Kanika is also on the exec team, um, on the external affairs team for the club. And before we begin, I just want to let you guys know that tonight we're going to be finally dropping the first episode of the podcast. And for that, I just want to thank a couple of people. I don't know if they're here, but if they watch the recording, they'll feel good about it. So first, I want to thank Khan for putting the design together. I want to thank Amanda for putting the animation together. I want special thanks to Prithika, Julia, Smriti for giving feedback, and Romina for giving feedback on the episode. And interestingly enough, one of the panelists today is going to be on the episode later this month. So if you guys are interested in being on the episode, the panelists, feel free to message me and we can set something up. So yeah, that's just the intro to the podcast. Now, Kanika, do you want to introduce the guests?
Yeah, so I'll start off with introducing some of the panelists that we have here today. So we have Gary, who graduated from statistics in 2015. He's currently working as an AI data scientist at Unity. We have Sylvia, who graduated from Math BBA double degree in 2016 and is currently working as a data scientist in product analytics with Uber.
And we have Jason, who I'm not sure if he has hopped on the call yet because he was a little late, but he studied computational math and applied math and graduated in 2017. He's currently actually working as a data scientist and a machine learning engineer at Stitch Fix. We also have Winnie Luong, who is a senior actuarial analyst at Intax Data Lab. She graduated in 2018 with an Act Sci and finance degree.
Okay, and all right, seems like we got all our panelists here now. So lastly, we have Alex, who graduated from Math BBA in 2019 and is working as a data scientist with Capital One. So I guess we'll go in order of graduation. So Gary, Sylvia, Winnie, Jason, Winnie, Alex, and whoever has an answer, you can contribute. Feel free to answer whichever ones you want to. So to start off with, maybe you guys can tell us a bit about why you chose data science as your career and what made you interested in the field.
So am I going first?
Yeah.
Okay. That's a hard question for me to answer because I didn't actually know what I was going to do even after I graduated. I just kind of fell into it. So at first, when I graduated from stats, I had trouble finding a job because I don't know how many of you guys are in the stats program, but during the stats courses, all you get exposed to is R, and nobody uses R. So I had R on my resume, and then I had LaTeX on my resume, and I'm sure the second one was what killed my chances, right? Nobody uses LaTeX. So eventually, when I did get a job, I did some reflection, and I realized that in school, I wasn't so interested in any of the subjects so much as solving the problem. So I like doing the assignments, but I hated writing out the answers. It would take hours, and I just didn't see the point of it. So eventually, I got interested in computer vision because that was around the time when all these startups started doing what is it, like cashless checkout like Amazon Go. So that was very interesting for me, and that was around the time when a lot of pose estimation came out as well. So I started doing a lot of projects on my own related to that, and that made me relearn all the machine learning concepts, everything that was taught in stats class, but except this time, I had to implement them. So that was how I decided I would pick this as a career. And after I think 1 or 2 years of working with that, I decided I was ready to start applying to like a actual data science roles.
Like
Yeah.
no, it's like a data science thing they were having. So I'm just gonna have it on.
So yeah, so that's how I picked data science.
I can go next. Yeah, so I think for me, it was actually a pretty natural path since my internship. So I actually did a couple internship in banking, and then I realized I didn't really like the financial environment. So I switched over to tech. So I was doing some like experimentation measurement with Facebook for my fourth internship. And then for my last one, I joined eBay for kind of just like a journal analytics, writing SQL to, analyze the business. And I was really lucky with the people at eBay. We actually like became really, really close. And eventually I returned there for my second year of full-time after I finished my first year full-time at Canadian Tire. So from Canadian Tire transitioning to eBay full-time, I was also focused on like model development and also like analytics kind of work. But at eBay, I was really given the freedom to do anything that I want. The team is just like, yeah, you just pick something that you want to do. So I focused a lot on experimentation for the team I was working for, which was marketing. So I did a lot of like experimentation on like the different ways of advertising. So that kind of like led to my current job, where I'm still doing experimentation, but all the previous kind of background or experience on like general analytics, finding product insights, working with stakeholder, all kind of like snowball into like where I am today. So I don't really have like like one big shot. It's more like kind of like making my way up to like where I am today. And I always have enjoyed looking at data, working with data, finding insights to help the team moving. So I guess that's why I pick data science.
So I basically just got really lucky back in college. So around my first year of university, I was studying theoretical physics. And what had happened was I had a friend of mine who introduced me to Andrew Ng's machine learning course for the first time, the first year that I was offered actually. So what ended up happening was I learned a program basically at the same time I learned machine learning and sort of carried the momentum through college. And then by the middle of university, I ended up doing most of my weekends was attending hackathons. And at some point I started like winning some machine learning hackathons and was like, recognized as like the data science machine learning guy. And then, I created a Facebook group with some people in it, and we sort of would have like weekly conversations, discussions about data science. And then at some point that got big enough that I figured that, hey, you know what, we should try doing something at the university. And then so a couple of friends of ours, we started the data science club. And that's basically it. Yeah. The reason I kind of made a decision to change something like physics to data science was mostly thinking about like the processes that generate data. When we think about science or experimentation, research could take like 60 years. And it's really hard for my like 19-year-old brain to wrap around the fact that like it might take like 30 years to build a laser just to measure like 6 things with it. Whereas, with a lot of things that are happening on the internet right now, the data comes a lot more readily, and sort of the analysis and the pace of the research is a lot faster. And so the research I ended up doing was things like looking at safety, online safety and like drug abuse on social media. I did stuff like counterterrorism and like, in child endangerment at Facebook. And it's all just about like, hey, I can like spin an electron really quickly and like weigh the electron, but I can also like read every tweet on the internet and like learn something about like all of humanity. And that scale and velocity was kind of the thing that made me sort of really interested as to what's going on.
Awesome. And so, hi everyone, my name is Winnie. And how I got into data science is different from our other panelists today. So, I graduated from actuarial science and finance statistics at Waterloo. And upon graduation, I started as the role of an actuarial analyst. So, not much into data science yet. And I certainly didn't expect myself to go into data science. But with a lot of the news, the hype behind data science around the time of my graduation, I decided that I did want to explore that field. And that was when it was starting to gain like a lot of popularity at Waterloo as well. It was around the time that Waterloo started their data science major option over there. So at my company, which is Intact Insurance, we had a whole department that started specializing in data science. And when a company that's been operating for dozens of years, just using like a more traditional GLM methods, less so with machine learning that you're familiar with today, it was a great opportunity to jump on that. Revolutionizing insurance was the reason that I dove into data science. And hopefully that's something that you are all interested in today, more revolutionizing an industry and being able to make things a lot better. That's the main reason that drove me outside of actuarial science and into data science.
Hey everyone, I'm Alex. And so yeah, I think my path's also a little bit unique. So initially, I remember when I was applying to university, like my family's all engineers, and I was always super into sports analytics. And because of that, I went to like a business and math degree because I read a random source online the day before. Said, hey, if you want to go to sports analytics, these are two great degrees. I'm like, okay, sure, I'll do that. And I guess that really just snowballed along the way. I think back in 2017, like it's tough because like in my program, I think everyone's driven towards certain programs. At the time, like a lot of my friends want to go to iBanking, and it's sometimes tough to separate yourself from the group. And when everyone wants something, you start wanting it too, and it gets a little bit confusing. But in 2017, I started doing some work on the side with Kitchener Rangers. And from there, I worked to automate all their processes. I worked with the team to create decisions and work towards like driving decisions with data. And from that, I gained a lot of experience just like coding and learning how to leverage data effectively. And then through that, I guess it just kind of flowed really well into data science. I mean, a few things that I enjoy there, like being able to drive decision making, like I've mentioned, the amount of communication and the back and forth that you have to understand the data and figure out how you can be leveraging it, like at least from a sports perspective, from a hockey ops perspective, and just the amount of collaboration. Like I really enjoyed it, and then from that, it just kind of snowballed. And then there's actually someone at Capital One named Peter Tanner. He runs Money Puck. So anyone who follows hockey, don't know if they're on this call, but he kind of said, hey, I think you'd really enjoy it here. And then that's kind of really what got me started in data science. And I've enjoyed it ever since. Wow, that was really informative, to be honest. I feel like I learned a lot. I have one question, which is that it seems to me that like you guys have graduated a while back, and well, not too long ago. I'm not trying to age you guys, but the data science itself has changed a lot since then. And the industries you're working in has also kind of changed with more data science practice as well as machine learning. So how do you feel that specifically your industry has changed with the advent of kind of data science becoming huge and machine learning becoming so popular? And how do you think data science itself has changed since you've graduated?
Order or everyone?
Yeah, same order. Same order.
Yeah. Okay, so first thing I want to point out is the data science of today versus the data science when it was first announced years ago by, I think, that Swiss statistician who coined it, the sexiest job of the 20th century or 21st century. I don't remember. So back then it was an umbrella term. Data science included statisticians, data analysts, and back then machine learning wasn't that big. But these days, it's an even bigger umbrella term. So you have to really understand what type of work you really enjoy doing. In data science, there is the data scientists who do much of the modeling. And then there's the MLEs who do the deployment. And ML ops is this new field that even Google is just figuring it out. Like no one really knows how to do it effectively. And then you have the BI analysts. They're under that umbrella now as well. They mostly write SQL queries, build dashboards. So, and then there's data engineering. That's the closest to software engineering. You do a lot of the backend stuff. So back then it wasn't so clear cut. Back then the thinking was just that you take a bunch of stats courses, and then you just analyze the data. These days it's not like that. I would say what's changed the most is the way companies look at these roles. So back then, I think everyone's seen that Venn diagram that has the hacker, the mathematician, and the business person, right? And then data scientist right in the middle. So these days, at a competent place, nobody expects you to do all three of those things. It's just way too much work. Usually you have yourself very nicely placed in maybe the intersection of two places, and some places even have you as in one of the circles in the Venn diagram. So I think that's the biggest change.
Yeah, I think I have a similar kind of thought as Gary. I think it's like for me, for example, I'm actually not a data scientist. I'm a product analyst within a data science org. So at Uber, we have two paths. One is data scientist and one is product analytics. So the only difference is for data scientists, you need to do modeling. So modeling is part of the competency. So it really depends on what you want. There's a lot of choice out there. If you just want to be more product focused, you're better at like solving product questions than like analytics is probably like a better choice for you. But if you want to focus on modeling, different companies have different kind of position. I know for Facebook, they have like something called machine learning engineer. They just focus on building models, and their data scientists are more like a product analysts. So the roles are a lot more defined, but again, if you go to startup, they probably ask you to do everything. So it really depends on company as well. But for bigger company, it's a lot more structured. And the second thing I want to add aside from this is data scientists or like slash product analytics have a pretty big say in more structured company these days versus before. A lot of the data analysis may be done by engineer or by some other like profession other than data scientists. Before it was more more defined. So like for example, for my role, like if I find some insight, I can completely block the entire product. If I say this is a bad move, we shouldn't do this, then they will actually take my advice and then stop doing anything before they can like correct it. So data science is actually really well integrated into the product. Whatever you define the metric, you define how to measure success. If and no one else can basically take that power from you, and you can basically veto a lot of things if it's like some like insight that you can provide. So that's like something I find like pretty powerful over time. Yeah.
Cool. Yeah, I'll approach it a little differently. So I would say that I got started around 2014 when things were still pretty new. This is like the Hadoop days. And I think there's like two things I noticed from now versus before, which one of them is like the roles now are a lot more specific, and sort of the expectations for what those roles like have are also much more specific, right? So I kind of like nowadays you can be a data scientist and you say analytics and people sort of know, okay, that makes a lot of sense, right? Versus machine learning, these are all like words that like people understand these days. Whereas, 7 years ago, like usually what you do is you say, I'm a data scientist, I have a PhD in astrophysics, right? And also what that means is the competition is very different as well, right? So, for like in 2014, if you were to apply for a job as an intern, most of the people you worked with were just academics who had transitioned into this field, having left academia. Whereas now, chances are like there are like data science interviews and there are like data science organizations, and we know how to hire for people with these specific talents, where like before it's mostly just like who has like a really cool sounding PhD. What this also means is that the career trajectory is a lot more clear, right? It's like these days it's really easy to just, you know, have access to data, train models, have demonstrations of like what you want to do, and have access to like to all that like knowledge, right? Whereas before, a lot of it is, you know, like you read some math textbooks and you like attend a Stanford course and you have some idea like how to implement these things in practice. But that transition from being like very vague to very specific has been really helpful for the industry. Like in particular, like the reason I made the data science course was I kept getting my ass kicked for software engineering interviews, right? Like what would happen is like companies would just hire software engineers who also were good at math. And that was like not sort of the right way of going about like hiring a data scientist. And now we sort of test more things like, can you design experiments? Do you have like a quantitative mindset? And that comes from the experience of having like really figured out like how to hire to be productive, right? Rather than just bringing like a team of PhDs and throwing them at problems.
I want to talk more about my field, so the insurance field, and how that's changed ever since I started university, which was 2013. So back then, we didn't have a specialized data science role in, I would say, for the majority of the company. And back then, the underwriters or whoever's in marketing would just do their thing. Maybe they have manual tasks determining where in Canada they should be doing marketing. And in terms of the actuarial science field, the actuaries were the ones coming up with how much money you have to pay 1 year if you want auto insurance. But how that's transformed since I graduated in 2018 was that we had a team of around I would say like almost a dozen data scientists and actuaries combined. And we were basically doing a lot of the tasks that those teams were doing previously. So that had changed and evolved since then. But now we're in 2021 and our team in Toronto has grown to, I want to say, like almost 40 data scientists and other specialists from different backgrounds. And that just goes to show you the popularity and how things have changed since years ago. In terms of the roles, that also means we're more specialized. So kind of like Gary mentioned earlier that back then, it was more general and now it's very specialized. Back then, a data scientist would also be doing some data engineering work. They would be cleaning the data, they'd be building the models and also implementing. But nowadays, we've gotten a lot more specialized and having a lot more specialized role, especially in large companies. I think that's something that you'll definitely experience if you chat with us in more detail. And of course, companies that are still small, you might still be, jack of all trades and having exposure to different things, which is nice too, because that means you get to choose what you like and hopefully specialize in there as the company grows. And that's exactly what we have, at least in my role. Like I noticed that didn't want to specialize too much in the data nor the implementation side. So more of like the building model side, like what kind of that domain that I was interested in.
So I won't talk too much about like Capital One in this case, because I think in a year, especially with pandemic, it's kind of hard to put a finger on how much it's like drastically changed and what was the root cause of it. But I can definitely talk a little bit about within sports and within hockey specifically, because I've spent a lot of time working with data from there. I think it's very like, I think like everyone here has brought really good examples, but in the industry, and I think the industry is obviously a lot further than like hockey, where they're still trying to figure out how to collect data, let alone to make decisions with it. But it's super cool to see how much that's progressed over the years. Back in the past, people would be like just talking about, oh, you have more shots on goal, you're doing better. But now it's like, all right, these attributes of this shot are more valuable. This team has this expected goals. And when this player's on the ice, like we have models now that can predict like what's the value of that player relative to everyone else. And so, I mean, at least from my perspective, it's been really cool to see in sports how rapidly they've been trying to pick it up. There's still like a long way to go. Within Kitchener, I think we're pretty cutting edge in terms of the Ontario Hockey League. But obviously, there's a lot more room to grow. But it's very interesting to see how like a lot of the bigger organizations and what they're doing has been trickling down. And I think a lot of smaller organizations, some of people mentioned, yes, they're doing a lot more, but it's exciting to think like where they'll get eventually as more and more of this stuff becomes more common in their industries.
Yeah, that was amazing. To be honest, I think we should have all of you guys in the podcast. I know I keep plugging my podcast, but I get a chance, so why not? I just want to mention before we kind of move on is that throughout each of the answers, something that I noticed is the diversity in the field of data science. That you don't need to be a certain kind of data science to be a data scientist anymore. And to whoever's trying to be a data scientist here, trying to get their first internship, you don't have to do the exact same thing that someone else has done. You can be a domain expert, for example, Vinny. You can be, in analytics, like Sylvia. You can be more on the machine learning side, like Jason and Gary. And you can be in, I guess he's a data scientist, but he's also talking about sports analytics. You can be in that as well. And finally, I also want to just add on a piece of knowledge. Gary mentioned MLOps being kind of the new field and interesting thing. And if you're interested in that, Chip Huyen on Twitter actually has really good content about MLOps. She worked at Snorkel AI. I'm sure some of you guys know her, but if you're interested in that, go follow her.
Okay, thank you, Jay. So I guess one of our main goals with this panel was to see how alumni have entered the field of data science. So my next question is more related to your undergrad. So you can answer this in any order. We don't have to stick with the same order we've been going with. So if you have something to contribute, feel free to add on. If you don't, that's okay. How do you feel that your undergrad degree at Waterloo, and so this can be like the courses you took or co-op experience, how do you feel that prepared you for your current job?
Yeah, I don't mind taking an initial stab at this. Honestly, in my opinion, I think the biggest thing that I got from Waterloo and from going to school was figuring out myself, like how I learn best. Especially for myself, I took very unconditional. I can't say I really tried too hard in school. I was very much, all right, let's get the grades to pass. I'm gonna spend like 60, 70 hours doing hockey stuff because I enjoyed that at the time, which looking back, maybe it's not the best choice. But the time that I did spend on school, like learning how you learn, I think in any industry, there's always gonna be new things that are coming up. And I mean, I know the others can speak a lot more to data science than I can probably on this regard, but there's always new things in data science. You're always gonna have to be learning and on your feet. And so understanding how to learn and understanding the importance of learning, I think that helps you a lot more, and that will push you a lot further in your career. And so as long as you leave school with that understanding of yourself, I think that's a really big thing to take away.
Winnie, do you want to go? Or? Okay,
Oh, sure. Okay, yeah, go ahead, Sylvia.
Yeah, sure. So I think, as I explained before, my kind of internship really helped me ramp up to my full-time job. If you guys are in co-op program, I think you have a really good advantage, and make sure you fully leverage that, and then kind of work your way up to get better and better internship over time. I think I probably would not have been where I am today if I did not do internship. Because I think at Uber specifically, the entrance bar is actually quite high. They require you to have like 3+ years of like work experience in analytics in order to get like the entrance level. A lot of people graduate from PhD and then land on that entrance level. So if you do have internship and then kind of leverage that, and I think Phi Co-op is like 2 years of work experience, even though they're not like full 2 year, but you do definitely have some experience from there. So I think the co-op program really prepared me for that. And also just like from school itself, like academic part, having some basic stat knowledge, like if you want to go into ML, then you definitely probably need a lot more courses to prepare yourself. But if you want to just get into analytics, understand the basic of how statistics works really help you to like get the ball rolling and running experiment, being able to explain to your stakeholder what does p-value mean, right? Because they don't really know the technical part of it. I also did a business degree on top of it. So I think that also helped me to kind of be a better communicator, a presenter, working, because stakeholder management is a key part of your daily job. Being able to communicate well, present your result is super important. And then on top of that, just like basic problem solving skills. I think Walu, especially like the technical programs really, although the assignments are really painful, really long to go through, but I think overall it practices your problem solving skill, like your approach, how you think. Those are also like, I think help me.
I definitely want to agree with Sylvia and add on the point where she mentions that communication is very important. I feel like this is definitely a skill that you learn from your different co-op terms, or for those that are not in the co-op program, well, from your internships or even volunteering in clubs. That's something that is extremely valuable. And we see the difference when someone graduates from Waterloo with co-op experience versus none. Like they do kind of jump into their full-time a lot faster, or they're able to work in a team well. And that's something I challenge everyone, and even the panelists, I'm sure, are building on this skill, but to be able to communicate this model that you built to, let's say, your boss, to the other departments, that's something that might not be extremely easy if everyone doesn't have the same background as you. So that's definitely a skill set. And even if you are in a more data science like specific field, and you work with, let's say, I work with like the Agile framework, it does entail daily communication, daily stand-ups, you have meetings and retrospectives and whatnot. So there's just a lot of communication, and that is something that you gain with more experience and you get more comfortable with more time.
Yeah, one other piece of advice that I want to maybe mention is, I mean, first of all, I definitely use a bunch of my Waterloo homework assignments at work all the time. Like I literally talked about like Cholesky decomposition last week. But one thing I think is super useful for people to think about when doing co-ops is, oftentimes people will go to the same co-op because they want to do the same work and because they've built relationships. But one of the most useful things I feel like I offer like smaller startups is having seen how bigger startups sort of organize themselves, right? And so the simplest example is basically like there's been a bunch of companies that literally like pay me money to ask me how I should help them with setting up their infrastructure. And every time I basically tell them what like Google and Facebook did, right? And you might be, working at Facebook and you might be working in a small part of the business, but you should spend a lot of time understanding why these decisions are made and learning how to make those decisions earlier, right? And at some point, when my friends do a startup, I help them get set up. I basically copy everything that Facebook did that I've seen in the past like 8 months of being there. And usually it's a pretty good, decision to have made because it worked, it scales. And, even things like how we think about like organizational structure. My company right now is going through a lot of change, and the biggest skills that I can offer are how I've seen management work at other companies. This has nothing to do with programming. This has nothing to do with math, but it's just sort of understanding like what are the best practices and how can I learn from these companies, assume that they've made the right decision and not make the same mistakes that they made, 4, 5, 6 years ago.
I think regarding the value of school, I think everyone's covered pretty much all there is. I wanted to say. It's just that I would focus on learning the way you learn. I think that's very valuable. So when I was a student, I skipped a lot of morning classes, for better or for worse. What ended up happening was I'd have to read the textbook to learn the material myself. So that turned out to be a silver lining because these days on the job, with the field moving so quickly, there are advances where you can use a new development to get a better performance on your model rather than spend all this time like fixing your data or doing whatever. So it takes time. It takes time to fix all these things where if you just try the new implementation, it may circumvent all the time wasted. So you have to understand the material, and a lot of the time this isn't something that was taught in class, so it's just useful.
Now that we're kind of talking about class, and I think Sylvia mentioned if you're into machine learning, you would want to take more courses to get into that field. Something that's kind of been on my mind because I'm in third year, and I think Kanika as well, and a lot of people listening, is the value of graduate degrees. So the question that I have is, in your opinion, what are the advantages and disadvantages of going into like a data science job straight out of undergrad versus doing a graduate degree first?
So I can't really answer for the graduate degree case because I don't have one. But what I find is working at places, a lot of the graduate students, they come on, they have this academic mindset. They start talking about all this theory. And then in meetings, the stakeholders, they just kind of zone out because really it's not important. they don't really care about what kind of model you use or what's wrong with the data or any technical technicalities, right? They just want to know if this has an impact on their business. And they want to know if, like what So was saying, p-values are important. They want to know if you can quantify this. So A/B tests are important. So for those who came out of undergrad and just went into data science roles, I find that they have a better business understanding. So that helps them, but at the same time, it can take away from their approaches to certain problems, because in grad school, you do get exposure to a whole new set of skills. Like a lot of subjects aren't taught at the undergrad level. I think at Waterloo, when I was still there, Bayesian statistics was just not covered at the undergrad level. But all my friends who graduated with a master's, like they talk about Bayesian approaches a lot, and you'll see these approaches in the cutting edge papers a lot. So there are advantages and disadvantages, but I wouldn't say it's something like it's something that makes or breaks the job, unless you're aiming for one of the top tier companies where, like at Amazon, their job postings always say you have to have a graduate degree, otherwise they just don't consider you.
I will add, usually when that's the case, the reason they want you to have a graduate degree is to get in contact with your research advisor. And so most of the time, the graduate degree is a PR link. So then your professor can now write papers with Facebook, for example, to make themselves look a little bit better. And you can't really blame them, right? That just becomes a matter of like, do you have the same connections, right? In which case, if you want to compare like a graduate degree with MBA to get a better job, then I don't think it's that worth it. Like fundamentally, I think you should go to grad school if you like love learning and you want to like think about a really hard problem for 4 years. But if you think about grad school as a way of like having a better job, then, like in this economy, compound interest over 4 years pays way more than the pay bump of a PhD, right? So, if you love learning and you want to like think about these hard problems, that is the thing that you should do. But if your goal is to like get a job, and I think for most people from Waterloo, like, hate it or love it, like we're pretty good at getting jobs already. I don't see it as too much of a concern. And also to be honest, like most of my team has a PhD, and like once you look a little bit older, like everyone just assumes you have one anyway, so it doesn't really count for anything.
I don't think it comes up in conversation anyway. Like people just, they just approach you as a colleague. Nobody goes to the lunch table and says, "Oh, this person has a PhD. I better not say anything stupid," right?
Yeah.
It's never like that.
The only time it ever happens is when a new person joins the team and they're like, "Oh, where did you go to your grad school?" And I was like, "Haha, sucker! I'm like 7 years old. I have so much to do and so much to learn." But yeah, I think for the most part, at least these days, it's a lot easier to get without, right? Again, like 4 years ago, everyone applying at a PhD, you may as well just like get a PhD on your team. But now between like a PhD and someone who actually build things, that becomes a different issue, because, it might be cool that you have like a PhD from MIT on nanotechnology, but like if you work at Amazon and you're selling like baby strollers, like maybe you don't really care that much. I do say though, Alex, at some point, I want to learn everything you know about hockey, because that sounds super interesting.
Yeah, I think I agree with Jason. I feel like, so my team specifically, everyone has master above, majority of them have PhD. I agree. I actually think they have more like theoretical knowledge. Like if whenever I run into a situation where I don't know how to set up a certain experiment, since not all experiments are basic as A/B, then I'll just like go to them, get their advice, pick their brain, and then see what I should be doing. But if you really just wanna, get into a job, I think there's a lot of online resources that you can just leverage, take some like, 4 months or 1 year part-time courses on the side if you need to, because wasting 4 years or 2 years in master you can make a lot more money, like if you just like full-time and kind of just learn on the way. So yeah, I'm not saying that you shouldn't do it, but if you love learning and you love like, building a network, having a group of like master or like PhD friends who specialize in certain kind of research or area, then definitely go do it. But just in terms of, for me, like I think thinking about like a trade-off, yeah, I would probably just do some learning on the side and then just start making money.
Yeah, I do want to echo the thoughts of the group. It does sound like, if I can sum up part of it, if you do get an offer from a company you've been eyeing, then go for it. Like you're getting a good role, you're getting good experience, you're probably getting really great pay, decent pay. You can, dive in there and then see where that takes you. There's quite a handful of people that I work with that decided 2-3 years later or 1 year later that they did want to pursue a master's. So now they're doing a part-time master's while working full-time. So that's kind of like a win-win. Of course, some companies do have that criteria. And if that's genuinely what you want to shoot for, then definitely I encourage everyone to do that. But I feel like once you get your foot into the door, people treat you the same, whether you have a PhD or master's or just an undergrad. And when it comes down to the day-to-day, it's more what knowledge do you have? And to me, I would still go to someone with an undergrad and a lot of experience in the domain, as opposed to someone who's a PhD and maybe they can't really communicate that well. They're not as valuable resource. So don't let that limit you.
All right. I guess Alex already talked. So first of all, I want to say I love this. These are spicy takes. My parents would hate that I'm actually having to go through this. They want me to do a master's, but this is validation for me. This is great. Something that I also want to add on.
Like, do you want me to have a master's or do you want to retire early?
Yeah, exactly. I should tell them that. That should be my like WhatsApp status if they know. But I want to echo Gary's point on Bayesian data analysis and Bayesian statistics. Nick actually, who's the reading group lead, is running a course on Bayesian data analysis this term. So if you're interested, hop on the Discord and go through that course. It's amazing. Yeah. Go ahead, Kanika.
Okay, so I guess this will be our last question, and then we'll take maybe like 1 or 2 from the audience. A lot of our members are beginner data scientists or are looking for how to start. So what advice would you give them for beginners with 0 experience in data science? Where should they begin? Should they go to Coursera, Kaggle? Do you have any other advice?
Once again, figure out what kind of work you enjoy doing, because that it's going to differ quite a bit. Coursera is useful for they write a lot of the boilerplate code for you in their assignments. Like when I got into deep learning, I took I think the Coursera course by the Moscow University of Economics or something. So they write a lot of boilerplate code for you, and you can see how things are done. So that's a good place to start. Kaggle is useful because everyone's really competitive there. They want the high score, right? So you get to see like what are the cutting edge things, even if they're just hacks to overfit to like the leaderboard data. So everything has different uses. I would say what's important is you pick one and then you follow through with it to completion. So if you start a Kaggle competition, and this is really hard actually, because it's very difficult to stick with something for like 2 weeks or like longer. Usually they're like 3 months, right? Without getting sidetracked or without losing motivation. But pick something, follow through with it, and then you can pick something else to try if you don't like it.
I think I'll take even a step back a bit. Like, so I'm not sure if everyone on this call has experienced coding, but I know for myself, like I've only really been coding for about 2 years now. And I think if you just try to get into data science, at least for me, it's super intimidating because there's so much you need to learn. Like all these stats that everyone's talking about, all these different models. And on top of that, if you've never coded before, like coding, and even if you're using like the Anaconda suite, which I know a lot of people use to start out, like that's a lot to take in. And so one thing that I find helped me a lot was just like finding things to code that I was doing already just to automate it and just starting small and then working towards that. And I think Gary brought up some good points about like, using some of those online like resources, looking over other people's code, and like those are great too. But I find that the hardest thing is just getting started. So I think just getting familiar with coding, getting comfortable on a console, I think that's a great first step. And then from there, it can really take off.
Yeah, to add on to what Alex was saying, when I eventually got my first job, I was actually doing web scraping. So when I had the first interview, I remember preparing for it, and all I could do in Python was, I think, open a file, write to it, and solve a bunch of like loop questions that you would see on assignments. That was the extent of my coding skills coming out of undergrad. And eventually you just have to get started, like Alex said. You pick things up, you start reading stack, and then you get to a point where you no longer just take the top voted question answer, and then you look for better alternatives, right? And then that's how you start digging deeper and deeper, and then eventually you just start reading documentation, and then even later you start reading the code itself, and sometimes you start writing your custom libraries just for yourself, and that's when everything takes off, I think.
I forgot if the question was more like preparing for ML kind of DS position, but if that's not the case, like you just want to focus on general analytics, SQL is definitely a huge part. Like for my daily job, I would say for the tools, I spend like 80%, sometimes more, just using SQL, because a lot of problems are actually not that complicated. You don't really need machine learning to solve a lot of questions. Simple analytics can answer most of the question depending on the stage of your team, but I think that's pretty sufficient. And SQL is super easy. You can probably like ramp up on SQL on like intermediate level within a few months of just YouTubing how people do certain like queries. And the other one I would say is like probably like do some case studies to understand, like, because you're solving problems eventually, right? Like when you're working even as a DS, and you need to understand like why are you solving this problem? What's the objective, right? Just having that kind of business sense, it would really help you to work with your product and your engineer peers. If you are just like focusing on like the data piece, you might lose the bigger picture. So I definitely recommend that. And then that is also a big part of DS interview. They ask you a lot of like case questions and how do you set up like experiment for these kind of problem. So yeah, that's my suggestion. And these are, I think personally, easier to learn than coding. Coding, like one, you need to kind of like, really get yourself to start learning. And then there's like different level of like difficulties in terms of like working with Python. Yeah.
Oh, another thing I forgot to say. So a lot of you who are in school who are not taking computer science classes, if you're just exposed to the type of coding that you do in art in stats classes, don't get into the trap of thinking that you have to write everything from scratch. That's a big that's going to trip you up a lot. I remember when I was doing the scraping thing, I thought about load balancing, so I started like reading on it, started writing it from scratch, and one of my colleagues just came along and said, "Why are you doing that? Just use AWS Lambda, right?" It saves a lot of time. It does the scaling for you. Learn to use the tools out there. So that's a big one. Like if there's a paper you're trying to read, you don't understand all of it, that's fine. Just go to the code repository, try to figure out how to get it running, and then run it a few times, tweak a few parameters. Like it starts with you getting your hands dirty, basically. That's what I'm saying.
All right. That was amazing. I'd echo all the points on coding and SQL, and some advice that I'll give is that if you're trying to kill both birds with one stone, try to make like a small web app with like a bunch of users and their login information, which you have to store in a database. So you'll have to write some queries, and you'll learn how to connect these two and learn some coding on the way as well. And SQL zoo.net, Kanika actually told me about that. It's a pretty good place to practice your SQL if you're interested. So now that we're kind of talking about tools and languages, etc., one of the questions in the chat from Niaz Abedeni, I hope I'm not messing up your name, I'm sorry if I am, asks what DS tools are more common nowadays and which ones are dying out?
Depends on the type of work you do again. One of the big ones I see is Kubeflow. So again, this ties into ML ops. There's quite a big gap between the software engineering skills of data scientists who just do all their code in Jupyter Notebook versus the ones who come from like a software engineering background where they can actually write things and deploy, and then like they use the CI/CD stuff. So I think this is just my opinion, but I'm seeing it everywhere that as time goes by, there's more focus on the coding part. There's a lot of focus on scaling and deployment. So initially, it doesn't matter what kind of tools you use, but for production environments, you definitely want to be using something that scales. Kubeflow is something that that does that. Being familiar with a cloud is important, but that you can learn on the job. There's also interoperability between like different platforms. That's kind of important as well, but usually that's offloaded to like the MLEs and stuff.
Yeah, I mean, the short answer basically is just like learn some Python, learn some SQL, right? Like, if your company requires Hive, that's basically SQL. If your company requires Spark, that's also possible to do in SQL. And whether or not that's like making training data using like a data warehouse, that you can do that in SQL. If you're using production data on like a Postgres instance, you're also using SQL. So like SQL is basically like really all you need to know. And really also what happens is if there's any new technology that does not use SQL now, it will probably use SQL later. And any like sufficiently new technology is probably too high risk to really like spend that much time investing in, right? Like I learned all of my Spark before Spark SQL exists. And so all of my knowledge of Spark uses this thing called RDD, and they basically deprecated that in like 2017. So, what a waste of 3 years. In terms of Python, I think that's primarily the skill you're going to be using, right? Unless you're doing like extremely stats-based or data aggregation-based work, like you might be using R, and I also prefer R in that use case. I think Python is a way to go, right? Like knowing Python, it should be like as important as like a chef knowing how to like hold the knife. You might not be able to make food that tastes good, but like at least you can sort of try to make stuff quickly enough that you can get that practice in, right? And obviously there's going to be things like Code Academy, which is effectively where I learned to code. But one suggestion that I really enjoy doing is actually sort of getting involved in the Python community, right? There are like really great speakers in events like PyCon and PyData, and they post those videos online for everyone to use. And when new people join my team and they need to get caught up on Python and they might come from a different background, there are like just a set of like YouTube videos that they should be watching, right? Like there's a really good one on pandas, there's a really good one on Python decorators, there's a really good one on generators, and those will give you the skills to build things fast enough and make enough mistakes now that you can actually become good at programming later, right? Like if you only know the basics, there's only so many like recipes you can try out before you graduate. But once you develop those skills, the speed at which you can sort of fuck everything up is dramatically increased.
So if you wanted a list of things, I would say for data engineering, like for scheduling stuff, Airflow is a big one. It's pretty popular. For tabular data, you want the gradient boosting libraries. So the fastest one right now, I think, is Cat Boost. It's made by Yandex. Look that up. And then for deep learning, there's so most of the papers these days are using PyTorch. So if you wanna run something real quick, you don't actually have to know PyTorch. You just download the repo and then you just follow whatever instructions they have. With TensorFlow, a lot of the research is still written in TensorFlow 1.x. So there's not much of a point learning TensorFlow just to be able to understand the research stuff, right? Again, you just run whatever's in the repo. Yeah, it's basically what Jason said. Yeah, the underlying connection is just Python. You learn Python, then you learn these tools as you go.
Yeah, and then once you know how to complain about Python, then you should be pretty familiar with it. Like once you start hating it.
Yeah, I would add that things are always changing. Like now we talk about all of this, and then maybe a few years from now, things are going to change. So kind of keep that mentality of being open to change and learning new skill sets, new programs and whatnot, even as you graduate and start years into the role. Yeah, I think it's always ongoing.
Yeah, those are, I think, great answers. I hope, I can't find the person anymore, but I hope your question was answered. I'd also suggest the same. Something that I'd actually add again, and I keep plugging Nick, but Nick actually keeps posting different things about like different technologies. Like recently, I think there's a tutorial on JAX. It's on our YouTube channel as well. So if you're interested in like learning something new, you can try that as well. I'd also say Fast AI if you want an easy PyTorch. And finally, before we end this, I just want to say this has been amazing opportunity for me. And so thanks, Kanika, for letting me do this. The first episode for the podcast is dropping tonight. I'm going to be talking to Jennifer Yee. She actually worked with Winnie and I about creativity, art, music, machine learning in music, etc. So I hope you guys, listen to it and enjoy it. And Winnie's going to be on one later this month. And if you guys want to be on the podcast as well, just hit me up and we can set it up. Thank you.
Okay, so just want to say again, thank you to all of our panelists for taking the time to speak to our students, and thank you for everyone for attending. So we're going to move into the networking part of this event. So I'm going to share the link in the chat. We're going to be using Run the World. Oh, the chat is not popping up. There we go. Okay, so that's the link we can join. If you are a speaker, there's a speaker group for you to join. For any attendees, you can join the attendee group, and then you will get matched to each other from there. So we're doing around 3 rounds. Each chat should be around 7 minutes. Hopefully you'll get a warning so no conversations get cut off. But yeah, at this moment, if anyone can switch to that room, and then we will begin the networking.
See you guys.
Yeah.
Bye-bye.